Okay na. Sige. So, a description of mathematical induction and the steps. Okay. Mathematical induction employs the domino effect. So, if we wish to let all the dominoes fall, then we simply have to queue them or line them up and then push the first, all the rest will follow. So for instance, if you would like to check whether there is truth to this statement that the sum of the first n positive numbers, or integers rather, or the sum of the first n counting numbers is given by n times the quantity n plus 1 all over 2, do we have to do it case per case, one by one? Do we have to get the sum of the first, get the sum of the first 2, the sum of the first 3, the sum of the first 4, the sum of the first 100, even the sum of the first 1 million? That is not enough to support your claim. Okay? So we have to employ a method in which we will be very sure that if it is true to the first and true to the second, then it must be true to all. Your mathematical induction. And so as mentioned a while ago in the previous slide, in the second slide, ito, the steps. In order that we can prove that this statement is true, or that this statement holds for any n natural numbers or any n positive integers, we have to show two conditions. Okay, the first condition, P of 1, P here is a proposition, that proposition or that conjecture which you would like to test. Okay, P of 1 is true for n equal to 1. This is called the base case or the basis. Okay, check whether the statement or the formula or the theorem or that conjecture holds for n equal to 1, wherein n is the first term, n equal to 1. So if n is equal to 1, P of 1 should be true. P here is a proposition. And an example of a proposition, P of x, and let x be, or should I say, a statement x greater than 3. So your proposition could take two values. Remember that from your previous sessions? Could either be true or false. So depending upon the value of x. Okay, so for instance, we consider the statement x is greater than 3. P of x could either be true or false. If x is 4, then P of x is true because 4 is greater than 3. If x is 2, then P of x is false. Okay? So condition number 1, P of 1 is true for n equal to 1. Okay? Condition number 2, the second condition. If P of n is true for n is equal to k, this is the assumption, okay? Then P of n is true for n is equal to k plus 1. If, okay, we assume that the formula or the theorem or the equation holds when n is equal to k, then we have to show that it is also true or that it holds when n is equal to k plus 1. This is the inductive case. So the first condition is the base case or the basis, and the second condition is the inductive case. P of k implies the truth of P of k plus 1. And P of n is true for n equal to k. This is the assumption or the inductive hypothesis. Okay? We assume that the formula or the proposition is true for n is equal to k, and then we have to show that it is true when n is equal to k plus 1. So going back, this is our target. We have to show that this formula, okay, holds for any n. Okay, for any n. How shall we show that? We follow the 3 steps. Okay? Prove that the sum of the first n natural numbers is given by this rule or formula. Or by the way, you know how to derive this. Remember from your history of mathematics when we dealt with figurate numbers. Okay, figurate numbers. 1, 2, 3, the first n counting numbers. Okay, or the set of natural numbers. The sum is given by n times the quantity n plus 1 over 2. N here refers to number of terms. If you can still remember, okay, we can make use of the quadratic function to derive a rule, okay, a rule that gives the sum of the first n natural numbers or positive integers. Let's recall. Tingnan ko nga kung ma-recall nyo. Okay, so paano nakuha yung summation of, this is concise way of writing 1 plus 2 plus 3 plus n is equal to n, let's go back to that slide, n times the quantity, n plus 1 all over 2. Okay? Just a bit of review, you know how to obtain this. Okay? So as fast as we could, para ma-refresh lang kayo. If we have 1, the sum is 1. If we have the first 2 terms, 1 plus 2 equal to 3. The first 3 terms, 1 plus 2 plus 3 is equal to 6. The first 4 terms, 1 plus 2 plus 3 plus 4 is equal to 10. Then you can come up with a table like this, x and then y. Remember this? Your quadratic function. 1 meaning how many, referring to number of terms. If we only have 1 term, then the sum is, let me use the proper number of terms. Okay, number of terms, and let the second be the sum. So if we have 1 only, 1, then the sum is 1. If we have 2, okay, from here, the sum is 3. If we have 3 terms, the sum is, if we have 3 terms, the sum is 6. If we have 4 terms, the sum is 10. What do you think will the sum be if there are 5 terms? Okay, from here, what do you think will be the next sum? 1 plus 2 plus 3 plus 4 plus 5, that would be 15. Okay? And then applying your differences, remember, taking the differences on successive values of y. Okay, 15, that's 5, 4, 3, and 2. Okay? And then again, continue getting the differences. Okay, 1, 1, 1. So, remember your quadratic formula. Sorry, quadratic function, I should say. Okay, if you could recall, this one is your 2a, and the first would correspond to the y value when x is equal to 1. So, in your y equal to ax squared plus bx plus c, which is the general form of your quadratic function, y when x is 1, what will y be? A plus b plus c. So this must be corresponding to a plus b plus c, whereas this value would be the difference between the first and the second y value. The second y value would be given by x equal to 2. Then that would be, this is by the way when x is equal to 1. And when x is 2, what will y be? Y will be 4a plus 2b plus c. Okay, so subtract or get the difference between the two. The difference will be 3a plus b. So now we can compute or find the values of a, b, and c. So from here, what is a equal to? 1/2. How about b? So for b, we have 3a plus b is equal to 2. But we found out that a is 1/2. So 3 times 1/2 plus b is equal to 2, giving b equal to 1/2. And c, look, if this is 1/2, 1/2 plus 1/2, that's 1. What will happen to 1 and 1 here? They'll cancel out, leaving c 0. Okay? So I don't have to show that now. C equal to 0. So a 1/2, b 1/2. Therefore, the sum will be given by, the sum is given by the formula k 1/2 x k plus 1/2 x squared plus 1/2 x. Okay? And since we made use of n to denote n to denote, okay, the number of terms, then the sum would be given by 1/2 times n plus 1. 1/2 is common to both. Okay? N squared plus n, sorry. Okay. Saglit lang. 1/2, or we bring out x. Sige, gawin muna nating n para 1/2 n squared plus 1/2 n. 1/2 n is common, or n over 2 is common to both. So, n plus 1. Or, just the same, n times n plus 1 all over 2. Okay? O, yun. Para maalala nyo. So, you don't have to memorize. You can derive it on your own. Okay? So, let's go back to the problem. Going back, prove that the sum of the first n natural numbers is given by this formula. Okay? So, let's go through the 3 steps of the inductive method. Move this to... Okay. Okay, so, condition number 1. Check whether the proposition is true when n is equal to 1. If n is equal to 1. So, let's see. Okay, 1 plus 2 plus 3 plus n is equal to n times the quantity n plus 1 all over 2. So, all we have to do is to simply replace n with 1 and check whether the left and the right side will be equal. So, if you have 1 on the left, then on the right side, 1 times 1 plus 2, 1 plus 1 rather, 1 plus 1 all over 2, 1 is equal to 1. Okay? So, it's true when n is equal to 1. It holds when n is equal to 1. Next, number 2, second step. We assume that the formula holds for n is equal to k. So, this is our inductive hypothesis. This is our assumption that 1 plus 2 plus 3 plus until the k term is equal to k times the quantity k plus 1 all over 2. Or we simply replace n here with k. So, we assume this to be true. This is our induction assumption or inductive hypothesis. Number 3, third step. We have to show that the formula is true for n is equal to k plus 1. So, if it's true for n is equal to k, it should be, or we have to show that it is true for n is equal to k plus 1. Okay? That the sum of 1 plus 2 plus 3 until the k plus 1 term is equal to. So, instead of k now, we shall now replace this with k plus 1 because referring to the k plus 1 term times what happens to k plus 1. If I change k plus 1 with k plus 1 or k here with k plus 1, it becomes k plus 1 plus 1. That's why we have here k plus 2 all over 2. This is what we are going to show. Ito yung palalabasin natin. Okay? Show that the sum of the first or the k plus 1 term, first up to k plus 1 term is equal to k plus 1 times the quantity k plus 2 all over 2. Now, remember from our assumption, okay, ito yung assumption natin kanina, no? Step number 2, okay, we assume it to be true that the sum of the first k, okay, first k natural numbers is given by, go back to step number 2. Ito yung assumption natin. Ito yung sum niya. So, I will write, instead of this, I'm going to write k times the quantity k plus 1 all over 2. Okay? Plus the k plus 1 term, okay? Plus k plus 1, which is the next term after k, must be equal to, this. Okay, so remember, this is our target. Ito yung target natin kanina. Going back, let's go back. Ito yung ating show that. Yan. Show that, yan, palabasin natin yan. That the sum of the first k plus first n, or k plus first natural numbers is given by k plus 1 times the quantity k plus 2 all over 2. Where shall we start? There are two ways, by the way, of proving. To prove, you could work on both sides, manipulate the left and the right side until such time that the two are equivalent or equal in form. Or, better yet, okay, you work on the more complicated side, okay, simplify it until it becomes, or should I say, until it is equivalent to the form, or should I say, to the other side of the equation, or to the right side. So, pwedeng work on the left side, make it equal to the right side, or work on both sides, manipulate both sides, and make the left and the right side equal. So, in this case, I prefer working on the left side. Make it equal to the right side. So, let me make use of another paper. Okay, so 1, once more, 1 plus 2 plus 3 plus k plus 1. Take note that k plus 1 is the next term after k. Must be equal to, okay, what is our target? Must be equal to k plus 1 times the quantity k plus 2 all over 2. Okay, now, from our assumption, from the inductive step, inductive hypothesis, this is equal to k times k plus 1 all over 2. If I then add the next term, which is k plus 1 plus k plus 1, then the sum must be equal to this. Okay? Take note that this is the sum of the first k plus 1 terms. Here, this is the sum of the first k terms plus the next term, which is k plus 1. The two must be equal. So, I'll work on the left side and make it equal to this. Okay, adding the 2, k times the quantity k plus 1 plus, okay, this one becomes 2 times k plus 1 all over 2. Okay? Addition. By addition. This is simply by addition. By adding. And then, from here, k plus 1 is common to both, so we could factor it out. Okay, factor out k plus 1. Let me use blue. K plus 1 is a common binomial factor. Okay, if I bring this out, then the other factor is, from here, we have k. I bring this out, then what is left? 2. So, k plus 1 times k plus 2 all over 2. What's the reason here? This is by factoring. Okay, or factoring out the common binomial factor. Now, is this equal to the right side? Obvious naman na, no? Pareho na sila. Is equal to the quantity k plus 1 times k plus 2 all over 2. Okay, that's it. So we were able to prove that the formula holds for n is equal to k plus 1. Take note that even 1,000 examples, 1,000,000 examples, hindi yun enough to support a claim or to test, okay, a hypothesis or a conjecture. Excuse me for a while. Something here? What did you press? Tell me. Which one? That's the J. Press something. See that? Changing the settings. Okay, sorry sa storbo. Okay, now we move on to the next. Are there questions here? Did you understand that? Okay, so let's go over. The first step is check whether the proposition holds, the conjecture holds, the theorem holds, the formula holds for n equal to 1. And then we assume that it is true for n is equal to k. And then number 3, we have to show that it is true to the next, which is k plus 1. And our starting point, of course, is our assumption. Kasi yun yung inassume natin to be true. Next. So now we have fulfilled both conditions of the mathematical induction. Therefore, the formula is true for every natural number. Okay? It's true for every natural number. True enough, you can verify. Hindi natin pala ginawa ito, no? So, going back to the given. So, if we have 1, the sum is 1. If n is equal to 1, then 1, okay, we verified this a while ago. If n is equal to 2, okay, 1 plus 2 is equal to 3. Check natin, if it's 2, then 2 times 2 plus 1, all over 2, this will cancel out, giving 3. Okay, tama. When there are 3 terms, 1 plus 2 plus 3 is 6. 1 plus 2 plus 3 is equal to 6. So that means 3 terms times 3 plus 1 all over 2. Is it equal to 6? Yes, because this is 4. 4 divided by 2, 3 times 2 is 6. Okay? And that's it. We now proceed to example number 2. Example number 2. Prove this time that the sum of the first n positive odd numbers, okay, first n positive odd numbers is equal to n squared. Okay? N squared. N squared. Now, let's check. N, or if n is equal to 1, the sum is 1. We have the first 2, meaning 1 plus 3, that is equal to 4. True enough, this is, okay, how many terms are there? 2. So, 2 squared. Tama. Okay, 1 term, 1 squared. Pag 1 plus 3 plus 5, what's the sum? 9. Tama nga naman, 3 squared. If you have 1 plus 3 plus 5 plus 7, what will this be? It's 4 squared, which is 16. Okay? Okay, so for specific or for a few cases, the formula holds. But how sure are we that this is true for the sum of the first n positive odd numbers? Okay? Again, we have to go through the steps of your mathematical induction. But prior to that, okay, this is the general form, okay, the general form of your positive integers. Add, okay, we have to be very specific, positive odd integers. Okay, Again, you can derive that formula from your linear function. Linear naman yan. Pakita lang natin para hindi nyo kailangan mag-memorize. So, we have the first add is 1, the second add is 3, the third add is 5, the fourth add number is 7, the fifth add number is 9. So suppose I'd like you to come up with, find the general formula for the set of positive odd numbers. Okay? So the first, we consider only the first 5. So the first odd number, 1. The second odd number, 3. 3, 5, 7, 9. Okay? So ang kukunin natin, paano i-derive yung formula kaya nila? So that if I would ask you the 10th, then you might, or should I say, you could easily tell me, the 10th must be 19. Okay? The 10th must be 19. The 50th must be 99, and so on. Okay? So, from here, we check on the differences, check on the consecutive differences between consecutive y values, and determine what function is manifested. So, let's copy 1, 2, 3, 4, 5. 1, 3, 5, 7, 9. Checking on the differences, ayan, 2, 2, and then 2. Okay? So, 2. What function is exhibited? The first differences along y values or among consecutive y values are equal. Therefore, this must be linear. Okay? Your linear function. And do not forget, your linear function takes the form y equal to mx plus b. Okay, y equal to mx plus b. So, if x is 1, where m here is the constant difference, which is m. Ito, paano yan pala? Then you can evaluate the function at x equal to 1. So, this is simply m times 1 plus b. So, the first value here must correspond to m plus b. So, ito yung m plus b mo. Okay? So, if m is equal to 2 and m plus b is equal to 1, therefore, b must be equal to 1 minus 2, b must be equal to negative 1. So, using the general form now, y is equal to m plus b, mx. mx plus b, ito pala is if x is equal to 1. Para hindi kayo malito. This is the function value or y value when x is equal to 1. But the general form or the point, slope-intercept form, y equal to mx plus b is y is equal to, your m is 2, x, and your b is negative 1. So in terms of n now, to be consistent, the general form of your positive odd numbers is 2n minus 1. Okay? Kaya yun. Kaya kung balikan natin, ayun. 2n minus 1. So now we go back to our mathematical induction. Check for n is equal to 1. We have already done that. Yan. Check for n equal to 1, 1 equal to 1 squared. Assume that it is true when n is equal to k. So our assumption is this, that 1 plus 3 plus 5 plus, okay, look, 2k. So 2k plus 2k minus 1, the sum is equal to, eto, look at this, n squared. So instead of n, k, using the formula for tama arithmetic progression, yung kay Jekris. Okay, k squared. This is our assumption. Now, we have to show, okay, show that, what are we going to prove? We have to show that 1 plus 3 plus 5 plus, what do you think is the next term? Ito yung general form, okay? Take note that this is the general form of, okay, n of a positive odd integer. Which means if this is the previous, then what's the next? Okay, the next is, you simply replace k here with k plus 1, making it, okay, making it 2 times k plus 1 minus 1 should be equal to, okay, we also have to replace k here with k plus 1 squared. Okay? Now, 2k plus 1. Correct. J Mark is correct. That's after simplifying. In fact, we could simplify this as 1 plus 3 plus 5 plus, okay, 2k minus 1 plus, you're right, 2k plus 1. Bakit 2k plus 1? Because this one becomes 2 and minus 1 is 1 equal to k plus 1 squared. Okay? From here, we now manipulate one side of the equation and make it equal to the other side. So I prefer I prefer proving in that manner. Work on one side and make it equivalent to the other side of the equation. Okay, so let's saan na yun? Saglit. Wala na tayo sa space natin. Okay. So let me copy. 1 plus 3 plus 5 plus 2k minus 1 plus 2k plus 1 should be equal to k plus 1 squared. But from our assumption from the previous step, we know that the sum of the first k odd integers is k squared. Okay? K squared. K squared ito. Saan galing yan? You might be asking me about that. Ito yung assumption natin. The sum of the first k is equal to k squared. So, from here to here, okay, k squared na siya. Okay? K squared. Okay? Plus 2k plus 1. We have to bring it into this form. Okay? We have to bring the left side into this form. K squared plus 2k plus 1. Okay? By factoring, remember this is a perfect square trinomial. K squared plus 2k plus 1 is a perfect square trinomial. I could express this in factored form as k plus k plus 1 times k plus 1 or k plus 1 squared. Now, and this is exactly the form that you can see on the right side. Okay? So, k plus 1 squared equal to k plus 1 squared. What's our reason here? By factoring. That's it. So, this is by factoring. By factoring. Now, we move on to the next. Other questions, by the way? Wala? Next. Example number 3. Prove that this law of exponent or rule of exponent is true for every natural number n. Okay, your natural number is 1 to infinity. Okay? That the quantity a b raised to n is equal to a raised to n, b raised to n. Okay, so we go through the 3 steps A raised to K. Ano yun? A raised to K. Sige. Tingnan natin muna. Okay, so going back, for n is equal to 1, check whether the formula or the rule holds when the power or when the exponent is 1. Okay, so when n is 1, then ab raised to 1 is equal to a raised to first, b raised to the first power, or simply ab is equal to ab. So check. Okay? So, the proposition or the rule is true for n is equal to 1. So, let's proceed. By the way, when the formula does not hold when n is equal to 1, do not proceed anymore to steps number 2 and 3. Now, we move on to number 2. Okay, state our assumption. Okay? That the formula is true when n is equal to k. So, AB, okay, the quantity AB raised to K is equal to A raised to K times B raised to K. Ito yung ina-assume natin na true. Now, we have to show that AB raised to K plus 1 is equal to A raised to K plus 1 times B raised to K plus 1. Okay, how shall we show that? Or what shall we do? We begin from our assumption. Okay? Begin from your assumption. The target is ito. Palabasin natin yan. Okay? So, for this particular problem, I shall be working on both sides. In the previous two problems, I dealt on one side and simplify, make use of properties, and then make it equivalent to the right side of the equation. For number 3 this time, I would like to work on both sides of the equation, okay? And make them equal. My starting point is the assumption. Kasi nga sabi natin true na ito. So from here, how do I come up? Ito yung question ko sa inyo. How shall I come up with an exponent k plus 1? Okay, so that's the target. Okay, let me start from AB raised to K is equal to A raised to K, B raised to K. This is what we want to come up with. This is what we want to arrive at. AB raised to K plus 1 plus or equal to A raised to K plus 1 times B raised to K plus 1. Our starting point is this. Okay? Ito yung starting point natin. Any idea? What should, let me see. AB raised to K plus AB raised to K plus AB raised to 1. AB raised to K plus AB. Plus AB, that gives, okay. Plus AB. No. Ito kasi ang starting point natin eh. Okay? We will not assume that this is true. Remember, this is what we are going to show. This is what we are going to show. And therefore, we have to begin working on the assumption. This is our assumption eh. AB raised to K is equal to A raised to K, B raised to K. So, multiply both sides by AB. So, we start from here. Multiplying both sides by AB, the quantity AB raised to K times AB is equal to A raised to K, B raised to K times AB. And then from here, what do we have to do next from here? Okay, look, the bases are equal. Remember this rule that, okay, the rule, para ma-recall din ninyo. Rule or one law of exponent says A raised to M times A raised to N, what is it equal to? A raised to m times A raised to n is equal to A raised to what? M. Yes, very good. Jekri said, add the exponents since they have the same bases, correct. Multiplying powers of the same bases, copy the base, and add the exponents. Very good. So, clearly, the bases are the same. And what is this implied power or the implied exponent here? Although it's not written, we are very sure that this is raised to the first power. Okay? So, we shall write this in a concise manner as AB raised to K plus 1. Kasi may 1 ito. Okay, implied yun. Okay. Yung kabila. Paano naman yung kabila? Yung kabila. By applying what property? Ito, ginamitan natin ng laws of exponent, di ba? Or law of exponent rather. Ito, bago natin magamitan ng laws of exponents ito, we first have to make use of a property, rearranging factors to be multiplied, rearranging numbers to be multiplied. Anong property yon? Arranging. Okay? Changing the places. Is it distributive? Starts with the letter C. Arranging. Pagbali-balig ta rin, parang 3 times 2 equals 2 times 3. 3 times 2 equals 3 times 2 times 3. 2 times 3 times 4 is equal to 4 times 3 times 2. Bali-balig. Commutative. Correct. To commute, do not forget, di ba pag nagko-commute ka, you go from one place to another. Kaya, commutative property because you are exchanging or changing the places, changing the order. Kaya nga siya commutative property. Distributivity has to do with grouping. Okay? Yes. Okay, so I could write this as A raised to K times A and B raised to K times B, and ultimately applying, okay, laws of exponent. This is now equal to A raised to K plus 1 times B raised to K plus 1. Is this the exact form which we would like to come up with? Ayan, tama? Ito. Ito, okay? This is exactly the form which we would like to show. Correct? So that AB raised to K plus 1 is equal to A raised to K plus 1 times B raised to K plus 1. Okay, so that's it. Okay. But there are other ways, hindi yung ito yung prescriptive. Meron din namang you start on the left side, make it equal to the right side. It's all right. It's all right. For as long as you do not violate properties, definitions, laws. Okay? Anyway, this is all justified. Every step is justified anyway because we could justify this by multiplication property of equality. Okay, ito could be justified by multiplication property of equality. Take note, this is an equation anyway. We can multiply on both sides the same number. And then next, what is the justification for this step? Okay, this could be justified by one law of exponent. Ito yun. Okay, multiplying powers of the same bases. And then this, okay, ito pala is commutativity. And then again, multiplying powers of the same bases. Now, we move on to example number 4. Okay, example number 4. Prove that 1 plus 2 plus 2 squared plus 2 to the n minus 1. Ma'am, ubos na po ang MB ko. Pang Google Meet po kasi yun. Ay, sorry. Anyway, available pa rin naman ito kahit na hindi kayo makapanood. Panoorin mo na lang later. Sorry, Robert. Okay? And then, yung solution naman, i-upload ko sa Lens. Itong file, i-upload ko sa Lens. Okay? So, available naman yung file after ng klase natin. Now, we move on to the next, number 4. Prove that 1 plus 2 plus 2 squared up to 2 raised to n minus 1 is equal to 2 raised to n minus 1. So, what is the form of these numbers? Okay, these numbers take the form 2 raised to n minus 1. It's the general form of the numbers. So, if I would ask you, what about the general form of your even numbers in terms of n? Okay, so your even numbers would be of the form okay, very good, powers of 2. Okay, so these are the powers of 2. I was about to ask that question, may answer na agad. Yun na, powers of 2. This is 2 raised to 0, 2 raised to 1, and so on. In general, we have 2, okay, 2 raised to n minus 1. Okay? 2 raised to n minus 1. The sum of the powers of n, of powers of 2 rather, is given by 2 raised to n minus 1. Let's check for n equal to 1. So, the sum of 1, isa lang naman siya, edi 1. Okay? Tama ba? So, i-verify natin. Is it equal to 2 raised to 1 minus 1? Are they equal? 1 is equal to 1. Okay, check. Okay? Next, assume that it is true when n is equal to k. So, this will be our assumption that 1 plus 2 plus 2 squared up to 2 raised to k minus 1 is equal to 2 raised to k minus 1. And the difference is this. Ito, yung minus 1 nasa exponent. Okay? Ito, minus 1 is a term. Nasa baba siya. This is our assumption. Now, we have to show that the formula is true for n equal to k plus 1. So that 1 plus 2 plus 2 squared plus 2 raised to k plus k minus 1 plus, what will be the next term after 2 raised to k minus 1? Okay, what's the next term? You simply replace k here with k plus 1. So it will be k plus 1 plus k plus 1 minus 1, k plus 1, sulat natin para di kayo magtaka, ano? Okay, 1 plus 2 plus 2 squared plus 2 raised to k minus 1 plus the next term after 2 raised to k minus 1 is 2 raised to k plus 1 minus 1. And according to the formula, this should be equal to 2 raised to, ito instead of k, will now be k plus 1, k plus 1 minus 1. Ito na siya. Okay? This is what we are going to show. 2 raised to, tama naman, 2 raised to k plus 1, tama. 2 raised to k plus 1, then minus 1, kasi meron ito. Okay? Which when simplified, magka-cancel out yan. Pag mag-cancel out yan, anong nangyari? Ito na lang ang naiwan. Okay? Kaya, 2 raised to k. Kuha? Kaya hanggang 2 raised to k. Ma'am, magtaka kayo. Bakit yan, ma'am, k minus 1? Ito, 2 raised to k. Kasi nga, kapag palitan. Okay? Palitan natin si k ng k plus 1, magiging k plus 1 minus 1, mawawala ito, di ba? So, ano maiiwan? 2 raised to k. Okay. So, ito na yung proof. So, we start from our assumption. Remember, this is our assumption. This is our assumption, step number 2. So, instead of this, I will replace this now. Palitan ko na to ng, okay, 2 raised to k minus 1. Kasi sabi nga natin from step number 2 that the sum of the first k, powers of 2 is given by 2 raised to k minus 1. Saan galing ito? Dun sa step number 2 natin. Ayan, no? Itong sum na yan is equal to 2 raised to k minus 1. So, ito, papalitan ko ng 2 raised to k minus 1 dito. Ito, tanggalin ko. I will be writing here instead of the expanded form, the sum, which is 2 raised to k minus 1. Kaya, ayun. Okay? So, 2 raised to k minus 1 plus What's the next term? Anong sabi natin kanina? The term that follows 2 raised to k minus 1 is 2 raised to k. 2 raised to k. So, ayun, plus 2 raised to k. What should the sum be? The sum should be of the form 2 raised to n. However, n is now k plus 1. Kaya 2 raised to k plus 1 minus 1. Okay? Now, we have to show that the left and the right are equal. Left and the right are equal. So, kahit hindi na ganyan, pwede namang ganito na lang. Or, so mamaya ko i-discuss yan kasi gumamit siya ng ibang variable. Or, I could start from here, 2 raised to k minus 1 plus 2 raised to k, is it equal to 2 raised to k plus 1 minus 1? So, let's not assume because we are still trying to show that the left and the right are equal. Now, if I combine, diba, these are like terms. Okay? These are like terms. 2k, 2 raised to k, plus 2 raised to k, edi dalawang 2 raised to k, right? Okay? So, I have to write 2 times 2 raised to k minus 1. Okay? Okay, what did we do? We simply added. Okay, we simply added. What did we add? 2 raised to k, isang 2 raised to k at isa pang 2 raised to k, pagsamahin, di naging 2. Okay, get it? 2 raised to k minus 1. Next. Okay, from your laws of exponents, what's our justification here? Addition. Okay, adding like terms. Okay, although I don't have space na kasi dito, kaya I will just tell it. Okay, justification, simply by addition. Adding like terms. Okay, next. Applying laws of exponents. Okay, multiplying powers of the same bases. Kasi ito 2, ito 2. So, we can combine. Okay, sabi ni J. Mark, very good. Okay, so, okay, we could write this now as, put these two together, pagsamahin na ito, powers of the same bases, we can write this now as 2 raised to, okay, the quantity k plus 1 minus 1. Ito ba yung gusto natin ipakita?
Mama,
Yes, ito yun.
Why do you keep saying 2
Okay,
raised to k?
so we were able to show that the left and the right side are equal. So, this is equal to 2 raised to k plus 1 minus 1.
Never say 2
Okay.
raised to k again. But why do you always say 2 raised to k?
That's it. Okay, number 5. Are there questions at this point? Are there questions at this point? Can you follow? What time is it? 4:22 na pala siya. May I leave this as your assignment then? Okay? So for number 5, this is what you are to do. I did not supply the general form. See? I did not supply, I purposely left this blank because I want you to derive the general form of these numbers. It's a linear function yan, ano? And the sum. I want you to derive a formula also that gives the sum. So after deriving a formula that generates these numbers, I want you also to derive a rule that gives the sum of these numbers and then prove by mathematical induction. So, go through the 3 steps. Yan, yan, at ito. Okay? Baka may sagot na. Dito may sagot na. Wait. Hindi na. In-upload ko na pala ang sagot. Okay? So, hindi na. Ito na lang siya. Ipakita nyo na lang sa akin paano nakuha yung 2n and n plus 1. Okay. And then for the next,
Not enough.
for the next, 1 plus 3, yung prove na lang, ma'am. Okay, yung last step na lang. Okay?
Last step
I want
na
you to show this part. Ito lang, this part. And then for number 6, I leave number 6 also as part of your exercises. Proving portion lang naman. And this one has to do with factoring, addition, multiplication. Next, ito naman. Okay? Last for this afternoon, kasi assignment na yung next slide. Last na, kasi it's almost 4:30. Show whether or not, see, you can prove or disprove. Show whether or not 3 raised to n minus 1 is a multiple of 2 by mathematical induction. Okay? So we cannot just prove series and sequences. We can also prove statements on divisibility, on being a multiple of a specific number. Okay? So we have to show whether or not prove or disprove. So dalawa, either prove or disprove whether 3 raised to n minus 1 is a multiple of 2. What do we mean multiple of 2? Divisible by 2, yes? If it is divisible by 2, or if we could show that it is 2 multiplied by a natural number, then we are sure that it is a multiple of 2. Okay? So, let's go through step numbers 1 to 3. Number 1, is this true when n is equal to 1? So, check natin. If n is 1, so at 3 raised to 1 minus 1, what is it equal to? 2. And 2 is a multiple of 2. Yes? Okay. 2 is a multiple of 2. Step number 2. Assume that this is true when n is equal to k. That 3 raised to k minus 1 is a multiple of 2. Ito yung assumption natin. Ngayon, anong gusto natin ipakita? Okay, we have to show that this k statement or this rule or this form 2 raised to n minus 1 when n is equal to k plus 1 is still a multiple of 2. Okay? So 3 raised to k plus 1 minus 1 is a multiple of 2. Ito yung i-manipulate natin. Ngayon, baligtad, dito tayo mag-manipulate. Ipakita natin na this could be expressed as 2 times something. Okay? We can express this as 2 multiplied by, okay, 2 multiplied by a natural number in order for us to claim or to show that this is really a multiple of 2. Paano yun? Now, let's manipulate. 3 raised to k plus 1 could be expressed in factored form as yung kanina na rule natin na a raised to m times a raised to n, a raised to n is equal to a raised to m plus n. So, instead of writing in this manner, we split na, factored form naman tayo. Okay? We express it in factored form as 3 raised to 1 times 3 raised to k minus 1. Okay. Ito, 3 times 3 raised to k, I could further factor this out, break this into, okay, I will break this into 2, dalawa na 3 raised to k, at isa, yan, dalawa na 3 raised to k, at isa na 3 raised to k. Okay? Because if I add anyway, 2 plus 1 is equal to 3. 3 times 3 raised to k. And what about minus 1? Leave it as it is. Now, this is our assumption. We said a while ago that 3 raised to k minus 1 is already a multiple of 2. Okay? It's already a multiple of 2. Therefore, yan. How about the remaining part? Ito yung remaining part niya. Since this contains a factor 2, we are very sure that this is a multiple of 2. Why? Because of this factor. Okay? The factor 2, the factor 2 makes this a multiple of 2. Meron siyang factor na 2 eh. Like 22. Is it a factor of 2? Yes, because I could express 22 as 2 times 11. So the presence of 2 here, okay, assures us that this term is a multiple of 2. Ayan, tama. Which one? J. Mark, hindi anak. Kasi ito lang, ang naka-raise sa 2 times. Hindi siya nakaganito anak. Ito lang. Ang 3, ganito siya. Parang nalito na kayo. 3 raised to k plus 1. Ito lang siya. Ito could be written as, okay? So that's it. So 3 here could be expressed as 2 plus 1. I hope you can follow. Okay? 3 here could be expressed as 2 plus 1. So that when we add the 2, 2 plus 1 equals 3, yan, times 3 raised to k. Do, diba si 1? Okay, so if I combine the 2, this is the same as 3 raised to k plus 1. Ito yun. 3 raised to k plus 1. Okay? So, 3 raised to k plus 1 minus 1. So, anong ginawa natin? Break it apart. Break it into 2. So, naging 2. Okay, you're right. So, pareho yung kay Jack Chris. So, ito siya. Ngayon, take note na yung pangalawang term, yung pangalawang parte, yun yung assumption natin. This is our step number 2. What did we say? In our assumption that this is already a multiple of 2. Yun yung assumption natin eh. O, hindi na natin gagalawin yan. For sure, this is a multiple of 2. Eh, yung first term, how sure are we that it is a multiple of 2? Ayan, there is a factor 2. Okay, 2 times 3 raised to k. Therefore, a multiple of 2 plus a multiple of 2, then the result must be a multiple of 2. And that way, we were able to show that 3 raised to n minus 1 is a multiple of 2. Okay? So, it's a multiple of 2. That's it. Other questions here? Ulit, klaro na to kung saan nanggaling itong 2 at 1. Si 2 at 1 ay galing kay 3. Okay? Dinistribute lang natin. Applying distributive property. In fact, ginamitan ito ng distributive property. Ayan, no? Okay? Bring out the factor 3. Okay. So, for your assignment din, ito. Similar ito, similar siya dun sa previous. Assignment, number 1, use mathematical induction to prove that 2 raised to 2n minus 1 this time is divisible by 3. Divisible by 3. What do we mean divisible by 3? Parang ganun din. It's a multiple of 3. Okay? And number 2, prove that the sum of the first n cubic numbers, cube. Bakit ganito? Wrong ito. May I make the necessary correction? This is not 2 over 4. This is equal to n squared times n plus 1 raised to the second power all over 4. Okay? So the sum of the first n cube is given by this formula. So this is for your assignment. In addition to this, along number na yung sinabi ko sa inyo. Ay, wag na yun. Okay, that's simple anyway. That one involves factoring only. Okay. Other questions at this point? there are no questions, then we could end the session now. Then your assignment, take note of this. Okay, 2 items only, and you can submit your assignment. You have until next week to submit your answers to the assignment. Sorry for the many interruptions this afternoon.